Good afternoon, dear colleagues. My name is Lytvyn, and today I would like to present my research project entitled Statistical Analysis of Factors Influencing the Incidence of Diabetes mellitus. The idea of this research is to apply statistical methods and modern data analysis tools to study the incidence of diabetes mellitus, to identify the main factors influencing its occurrence, and to construct predictive models of morbidity dynamics. The purpose is to conduct a comprehensive statistical analysis of diabetes morbidity to examine the impact of medical and demographic indicators on its development, and to build forecasting models using both classical statistical models and modern machine learning approaches. The work consists of two main sections. In the first section, I worked with time series dataset on the incidence of diabetes in Kyiv. Since this dataset represents temporal dynamics, specialized forecasting methods were required. Using the R programming language, I calculated descriptive statistics, visualized the data, and constructed time series forecasting models. In particular, ARIMA process the regression analysis to predict morbidity trends in Kyiv. In the second section, because no suitable dataset on individual medical indicators was available for Ukraine, I selected a publicly accessible dataset from United States. The dataset is useful as it contains detailed medical records of women, including the number of pregnancies, glucose level, blood pressure, and body mass index. Based on this data, I applied statistical hypothesis testing specifically the student's t-test, compare mean values between healthy individual and the patient with diabetes. Additionally, I developed predictive models using three machine learning models, Kanya neighbors, random forest, and logistic regression, and compared their classification accuracy. In chapter 1, we begin with bar chart. The blue column represents children already diagnosed with diabetes, while yellow columns show children whom diabetes was detected for the first time. The data are presented across different years. Next, I explore the data in more detail and constructed box plot for children with diabetes and for those newly diagnosed. On the slide, they are marked as P and FP. I also included a table with basic data, with basic statistical calculation to better illustrate the dataset. Here, I worked on forecasting the incidence of diabetes among children in Kyiv. First, I construct a linear regression, and then I applied the ARIMA model to perform time series forecasting. In chapter 2, unfortunately, no suitable dataset was available for Ukraine. Therefore, I used an open access dataset from United States. It proved appropriate as my goal was to identify factors that influence the present or absence of diabetes and those that help its detection. The dataset includes 9 medical indicators and cover more than 700 women. This slide presents the matrix of contrast and pairwise correlation coefficient. Please pay attention to the last column with box plot. The red plots represent healthy individual, while the blue plots shows patient with diabetes. When the mean coincides, it means that the factors likely does not influence the presence of diabetes. If the difference is significant, the factor is likely relevant. To validate this significantly, I applied the student's t-test. Result revealed statistically significant difference between healthy and diabetic individuals for factors such as the number of pregnancies, glucose level, insulin, body mass index, diabetes pedigree function, and age. No significant difference were found in blood pressure and skin sicknesses. Another object was to build a machine learning algorithm capable of predicting the presence of diabetes based on various factors. For this purpose, I applied three methods: Kanya neighbors, random forest, and logistic regression. On slide 11, you can see a comparison table of their performance. If we are interested in overall accuracy, logistic regression performed best, reaching about 78%. However, if sensitivity is more important, random forest is perfect method will achieved around 88%. Thank you for attention.